Is there a table method that would help you right now as another method? So in addition to whatever you might have used, how might tables work for you? Okay, so I'm just kind of gonna, and did we figure out a quart, 2 quarts, how many ounces is that? 2 quarts, do we know how many ounces that is?
64.
64 ounces,
Yeah.
okay, so we're kind of on the same page with that, okay? So you might have a couple methods. Can you use a table? Can you? What would it mean to be setting up a table for this right now?
7 ounces. 3 eggs.
Wait, how much is 2? Okay, so can I get a volunteer to kind of come up and put up a method? Where are my overhead bins? Okay, can I get a volunteer here to kind of put up a method? Can you go ahead and put that up? You don't have to or go ahead and include it if you did it. So go ahead and just on the board. Okay. So what was one of the methods we had before? Or did you use the Maybe it is. Maybe it is. Like, I was just trying to look up. Why don't you go ahead? You just go put that up. Anybody else have a different one? Okay, let me say that. We'll give some about that explanation. We figured out how many ounces. Oh, good. Can you put that up? Okay, good. Put that up. That's a good one. Okay. How about you guys? Let me see some of your methods. This one? Oh no, this. So you went to 48, right? So I kind of, what was your method? Oh yeah, can you go put that up? Okay, just like this? Or, pick a space over there and just go ahead and put up. I'll ask you to explain it. Okay, so we've got a couple of different solutions coming up. Yeah, you did. Heard you. Teacher voice.
So many ways to do it.
Thank you.
It's similar to what?
Yeah. But it's still a little, it's got to make a difference, right?
Okay. Yeah.
What train did you take?
Is that it?
Great, great, great.
The tourist bus. 1-8?
Yeah.
And what is this? I can't think.
Faster. Let me get 10.6.
10 and 4 out of 6.
That's okay.
That's good?
Yeah.
Cool. Okay. So, what are strategies that you have to share with us on how we make sure students are going to feel comfortable putting both correct and wrong answers up to be discussed? Okay. First of all, actually, let me step back. Do you see a value in a wrong answer being posted?
Yes.
Okay, so we could talk about that, but I'm actually going to say, how do we make kids feel comfortable? At the beginning of the year, we're setting up the environment of that class. And what are little things you do to ensure that kids can feel comfortable and not stressed? So there and then there. Yeah. Go ahead.
Me?
Uh-huh.
I have an extra credit book. I need the extra credit because as long as you put up the answer, it doesn't matter if it's wrong or right. You get the same credit as if it's right.
Okay.
And you
Nice
know
little
what you say
motivation.
against the person.
Right. Yeah.
Get something wrong yourself.
Ah, nice. Right. Every time we do that all the time. So
And laugh about it.
Laugh.
And cares. And life goes on.
right. Nice.
I was going to say the same thing she says, and even that, it's a struggle sometimes to get them to go, and I constantly have to remind them that it doesn't matter the effort, that's all that counts.
I give more credit for the process. So the answer doesn't really matter. It's more like, show me you started the problem and you were part of it, and that's just as good.
Right. Okay. Just so you know, the math problem we're going to work on tomorrow, I did the whole thing with the wrong numbers when I worked on it. Right? But I think these are important little ideas, right? And then sometimes there's a real importance in them seeing what has to be reconsidered, or how do we sometimes step back and say, okay, is this a reasonable answer? Right? It still is, what is the nervousness and anxiousness that we can feel sometimes, regardless, when presenting to some new group, right? As teachers, maybe we've reached some different comfort points, but in other situations, most of us can say, yeah, I know what it feels like to get a little nervous about doing something like this, right? Okay? So it's just certainly an important thing for us to kind of be ready to think about. Okay? Okay, so let's talk about some methods here. Okay? let's go ahead and start right here. Can we see what's going on? Can people see the numbers? Who did this one? Can you actually come on up and point and tell us what you did?
I had another table, I just didn't put it up here though. It was
Okay.
to get the ounces, the 64 ounces. So I knew that I had to get to 64, but when you count by sixes, it doesn't work. So then I just figured out in my head, obviously, which you can see everyone has the ratios. I figured, all right, it goes up by 6, this goes up by 3, so I count by 2s, that goes up by 1. I got the 32.
Any questions for him? Is this a is this a method where he has some kind of extra skill in proportions already also, right? We could actually say that adding 6s, you're adding 6 here, so then
Three there.
you're adding 3 there, right? And you kind of, you said you had a longer table, right? Okay. The jump from here to here and maybe then breaking this out is a more complex thinking, right? So what is it? So we could see a kid going from here to here, right?
Then they should at least have it narrowed down to what close.
The lemonade's going to taste pretty good at this point, right? Whether they put this or this in it,
But
or
they're going to
picking
go somewhere in between.
somewhere in between. That's pretty good in terms of the reality of proportional thinking. Like when we talk about the realness of a problem, this lemonade's going to taste just fine. Okay? We still have, different kids might be ready for this, some may not be. So we can kind of come back and think
I
about
think the
that.
hardest part though is the 64.
Yeah. Well,
Because there's, you got the ounces, cups, quarts, pints.
it's a whole other problem within it, right? Yeah, that's true.
I
Yes.
thought you could say that maybe even the answer could be given in a range kind of form. If you're using table, like I would say, I will use between 30 and 33 spoons of the mixture. And then I will also say, I was adding over here, I like my lemonade stronger, so I'm going to add 40.
So you're going to lean towards more rather than love, right?
Right. Have that flexibility and kind of real
Right.
sense
A
of the
real-
problem.
Okay? Okay, yeah.
Well, a lot of times they don't have 3 tablespoons in the house, so they have like 1 tablespoon. Okay? So they may take the 1 tablespoon and find what the ratio is to that to 6 ounces, and come up with the 2 ounces, and then just.
So that's kind of interesting, right? That bringing in a teaspoon to tablespoon actually
Well,
does.
a tablespoon to, instead of 3 tablespoons of 6 ounces, how many ounces is 1 tablespoon? And then kind of go.
Okay, so how many ounces is 1 tablespoon? So we could get the table, I'm going to go up this way, right? I could just be adding it here too. But you're saying if 3 was for 6 ounces,
Right.
1 tablespoon would be for 2 ounces. Okay? Okay, right? And then what? Okay, so that's a nice piece, right? That may help fill in here with that table, right? Now this, who did this again? Hi, can you come on up? Tell us what you did, and then we'll connect it, or you can connect it. Yeah. So what did you do?
I essentially came up, for lack of a better unit rate so for every ounce of water, you're going to need a half a tablespoon.
So you knew unit rate. You said, how did you get the 0.5? How do we get the 0.5?
Because 3 is.
You could go back in the table, go one step further.
Yeah, you can do a table. You can think about it, right? Okay. So, and what do I mean by when we say go back? What do we mean by go back to the table? What does it mean?
You could break the 2 into 1 just to find the unit.
I can. I can kind of keep going here right now, right? So if 1 is 2, then a half would be to 1. And so 1 ounce to 1/2, okay? So now does that help me?
For everything, oh.
Unit rates, okay. So the power of unit rates, okay? Being able to think about unit rates, okay, is really huge. The power of tables in this, okay? And being able, so again, when we think about that language of the different definition, being able to scale up or scale down with that problem, okay? So this is kids really thinking proportionally. If we can get them to kind of find a utility in this. And the way that we could use, that we can kind of connect the unit rates with the tables, right? That's a powerful piece here, okay? Okay, so what do we have here? Who did this one? Can you come on up?
So first I found how many ounces were in 2 quarts. We said 8 by 8. And then I saw the relationship here was 6 to 3, which then I thought 2 to 1.
Okay, hold on, let me pause you. How many ounces were in 2 quarts, and where did this come from? 8?
So 2 quarts is 8 cups, and each cup is 8 ounces.
Okay.
So a total of 64 ounces.
Okay. Okay.
So the relationship here is 2 to 1, so then I said, okay, if this is also going to be in 2 to 1, what's half of 64? 32.
Okay. Okay. Nice, right? That's kind of cool. Just do that. Okay. Nice. Nice and quick. Okay. And then what about this one over here? Yeah, can you come on up? Liz.
All right. So first I wrote how many tablespoons per ounce and per 6 ounces. I knew that my end goal was quarts, but to get to quarts I'd have to go through cups, pints. So I skipped pints apparently completely. That's okay. So I'm like, I need to get to some factor or some multiple of 8. So I went to 48 because I completely forgot that 24 existed. Yeah, exactly. So I forgot that 24 existed, so I went to 48. And I converted the 48 ounces to cups. The math here was from here to here, and then I just knew that was 6 cups by dividing by 8. But this stays the same because math.
Pause. People, wait. Let's just pause for a second, right? Let's check for understanding. Because what did she do? And what did she just rely on to go from this fraction to this one? What did she just rely on? What did she use?
She converted ounces into cups.
Yeah. Okay. Keeping the okay.
All right. So then I realized that I wasn't going to make 6 cups turn into 8 cups in a pretty way, so I needed to bring it down to 1 cup.
So you there's a little bit of a unit rate. There's equivalent fractions here, and then there's a little bit of going into utilizing unit rate also.
And then I wanted 8 cups, because that's what it says. So I turned it into 8 cups, 32 tablespoons, and I just showed that was 2 quarts. I just couldn't remember.
Okay.
I didn't.
Okay. Thank you. Okay. So I'm just going to kind of add here again the equivalent fractions. Right? And then here we're kind of looking at a ratio here, right? Keeping the ratio the same. Right? Okay. So with this problem, and there are a lot of different methods that can come up on how students might solve problems like this, right? Okay. So what we're going to do right now is kind of do a walk-through of some sample problems. Okay, a walk-through of some sample problems. Push to the next slide.
Sure, yeah. Can I interject a little?
Sure.
So, what's going through my head for the lemonade problem, at least? Anybody drink lemonade or iced tea or yeah, right? And you make your own. You get those jugs, right? How big's the jug? It's actually 2 quarts usually. So, are you going to be able to fit 2 quarts and 32 tablespoons in one jug? No, because it's going to overflow, right? So how could you actually fill that particular jug? How much is water and how much is lemonade? Put it more into the real world, as opposed to this very kind of math-oriented problem. I think that's something that we want to kind of push our students towards. Thinking about this, I'm filling up my lemonade jug. The whole thing is 2 quarts. I don't want to fill the whole thing with water for 2 quarts, because then I'm not going to have any room for lemonade. So you may want to extend this even further to figure out, well, I know that I want this mixture to be fully 2 quarts. How much does that need? And you may need another conversion up there that wasn't provided.
Or another jug.
Well, yeah, another jug, right? But I believe 1 ounce is 2 tablespoons. So you can actually extend this problem fairly easily forward, and you get a nice ratio. The numbers actually aren't a nice, it's not a nice number. It's not a good fraction. It ends up being like a ratio of 4 parts water to 1 part. That's where you may want to go with students who maybe they're bored with this. If you have a class of mixed levels, you can give that option to some of the more advanced students while the others are working on the basics.
Okay, so what we're going to do first of all is we have 2 things that we're going to be trying to do in the next hour or so. Okay, one of them is to just be familiarizing ourselves with kind of sequences of problems. Okay, and then on a small note, we're just going to kind of talk about a particular lesson and the structure of it, so that this binder can kind of make a little more sense. Okay? So what I'd like you to do is we're going to work, so these problems are really kind of just selected so that there's 1 problem from each of these, 1 or 2 problems from each of these different sections, so that you can kind of, as you work through these, you can see a little bit of the progression of what's happening with these problems. Okay, so the lemonade problem is actually a little bit more in the 3-point-something section on using tables. That happens to be where that lemonade problem pops up. But so go ahead and get started on this. So there's a few instructions as you're going. Okay. So like for the first couple of problems, do the math, and I'm asking you to kind of just stop and share in your group after a section. So let a section be, so for example, it starts off with 1.2, okay, and there happen to be 2 problems. So go ahead and do those 2 problems, and then have a brief little conversation in your group about how you did those problems. Okay, sharing your method. Okay? And I'll be kind of interrupting you with a few extra problems to look at.